Hey guys, Miss Gosling here. In this video, we're going to talk about gravitational fields when there are multiple objects present. By the end of the video, you'll be able to determine the gravitational forces on objects when there are more than two objects in a system. So let's go ahead and get. So the easiest way to think about the gravitational force if there are multiple objects is to think about field strength. So to do that, I'm going to look at each of these objects. So I'm going to start with my red object. So my red object and my blue object are separated by a distance d. Let's go ahead and say that blue and purple are separated by the same distance d. That means the distance from red to purple is, of course, 2d. I'm also going to say that the red object has a mass m, blue has a mass blue, and purple has a mass, which I'm going to write in purple. So if I look at the gravitational force of my blue mass on my red mass, my blue mass is going to pull my red mass to the right. So that's my force of blue on red. My purple mass is also going to pull my red mass to the right, but it's not going to pull the mass quite as strongly because the distance between purple and red is much larger than the distance between blue and red. The only exception here is if purple had significantly more mass than blue, which is, of course, very possible. So we're going to see almost exactly the same thing for our purple mass. My blue mass is going to pull the purple mass towards itself to the left, so that's my F of blue on purple. And my red mass is also going to pull the purple mass towards itself. That's going to be the force of red on purple. But again, the force of the red circle on the purple circle is going to be much smaller because, again, they are much farther away. However, what you've noticed, hopefully, is that these arrows are pointing in the same direction. The reason for that is that my purple object and my blue object are both going to pull my red object towards themselves. So both of them are pulling the object to the right. Similarly, the red and blue objects are both pulling the purple object towards themselves. So they're both pulling the purple object to the left. For the blue object, of course, it's a bit more tricky, right? So the red object is going to pull the blue object to the left, and the purple object is going to pull the blue object to the right. And what's really cool is if the red object and the purple object have the same mass, the total force on the blue object will actually be 0. Now, if they have different masses, the spot where the force is 0 is going to be somewhere else between them. But what's kind of cool is when there's multiple objects, we can find places where the total force, and therefore the total gravitational, well, let me back up. If we have multiple objects, we can find a spot between two of those objects where the total gravitational field strength, and therefore the force on any object placed at that position, is going to be 0. So here's the theory. Let's go ahead and get into some of the nitty-gritty. And we're going to do that by looking at example 1. So solar eclipses occur when the moon passes between the Earth and the sun. So let's go ahead and pause. We're going to draw a picture. So let's start, and we're going to draw the sun. I'm going to draw the sun as a little star. We have the Earth, which I'm going to make a nice blue dot. And we have the moon, which I'm going to make a little smaller black dot. Because it's really important that we know that the moon is between the Earth and the sun for this question. So when a solar eclipse happens, the moon is 3.84 times 10 to the 8th meters from the Earth. So this distance here is 3.84 times 10 to the 8th meters. And the moon is 1.49 times 10 to the 11th meters from the sun. So that means this distance here is 1.49 times 10 to the 11th meters from the sun. The moon has a mass of 7.35 times 10 to the 22nd kilograms. So that's 7.35 times 10 to the 22nd kilograms. The Earth has a mass of 5.97 times 10 to the 24th kilograms. And the sun has a mass of 1.99 times 10 to the 30th kilograms. First, we're going to calculate the total gravitational force acting on the moon. So what I'm going to do is I'm going to go ahead and I'm going to draw arrows representing the force of the Earth on the moon and the force of the sun on the moon. So the Earth is going to pull the moon to the right, and the sun, in my picture, is going to pull the moon to the left. Now, I will clarify, obviously, we are not looking actually at things going left and right. We're going towards the sun or towards the Earth. But I'm going to use left and right to simplify things. So what we're going to do is we're going to calculate the total force acting on the moon. So I know that the force on the moon is going to equal the force of the sun on the moon plus the force of the Earth on the moon. And these are both vectors. Looking at my picture, the force of the sun on the moon is to the left, so I'm going to go ahead and make that negative. So I'm going to say the total force on the moon is equal to the force of the Earth on the moon minus the magnitude of the force of the sun on the moon, since they're in opposite directions. So this is equal to the gravitational field strength times the mass of the Earth times the mass of the moon divided by the distance from the Earth to the moon squared minus g times the mass of the sun times the mass of the moon divided by the distance from the sun to the moon squared. In other words, this is equal to the mass of the moon times gravitational field strength of the Earth at the position of the moon, so at the distance that the moon is away from the Earth, minus the gravitational field strength of the sun at its distance from the moon. So plugging those numbers in, I get that the force of gravity on the moon is equal to the mass of the moon, so 7.35 times 10 to the 22nd, times 6.67 times 10 to the negative 11th, times the mass of the Earth, which is 5.97 times 10 to the 24th, divided by the distance from the Earth to the moon, which is 3.84 times 10 to the 8th, and we're going to square that whole quantity. And from that, we'll subtract the gravitational field strength of the sun, plugging in numbers the same way. And what I'm going to go ahead and do is I'm going to go ahead and plug in each of these equations separately. So that way I have the magnitude of the field strength of the Earth at the position of the moon and the sun at the position of the moon. So when I do that, I get that the force of gravity on the moon is 7.35 times 10 to the 22nd times 0.0027 minus 0.00598. And when I plug those numbers into the calculator, I get that the force of gravity on the moon is negative 2.4 times 10 to the 20th newtons, or 2.4 times 10 to the 20th newtons towards the sun. And I'm going to go ahead and skip the last two parts of this problem. I think that you guys can solve this on your own. But if you would like to see me do the other parts of this question, I will have a supplementary video where I solve the full problem solve parts B and C of this question, in addition to solving part A. So with that, we are at our takeaways. So first of all, we can determine the gravitational force or field in systems of more than one object by adding the gravitational forces or fields due to each object together. Second, it is important to pay attention to the direction of a gravitational force when determining the net force on an object. So with that, you've now learned some more complex systems. Best of luck and happy solving.